Namaskar, welcome to this lecture. I am Dr. Anita Kumawat from the ICAR-Indian Institute of Soil and Water Conservation, Research Center, Kota. Today I will be speaking about the conservation agriculture, its principles, practices and ecosystem services which it provides, and we will also explore that how conservation agriculture can help to build a resilient, productive and sustainable future. So let's begin with that. Why this is important? As we know that healthy soils are the foundation for producing the healthy food and for a healthy environment, and soils also provide the fundamental ecosystem services like supporting life, climate change mitigation, carbon sequestration, nutrient cycling, biodiversity habitat and many more. But unfortunately, this vital resource is under growing pressure of the land degradation as well as unsustainable agricultural practices. So now, if we define land degradation, then as per the International Union for Conservation of Nature, it is a decline in the land quality either by the direct or indirect human activities that results in the loss of the biological production, ecological integrity and human worth. Worldwide, it affects around 25 to 30% of the global land and more than 40% of agricultural land, with an estimated 24 billion tons of the soil loss every year. In India, there are about more than 120 million hectares of the land is degraded, with an average soil loss of 16 tons per hectare per year. And out of this 20 millions of the degraded land, the most prevalent form of the degradation is the water erosion, followed by the wind erosion and chemical degradation. Thus, this degradation is the major challenge for the food security as well as ecosystem health. Now the question is that what are the major drivers and impacts of the land degradation? So land degradation is basically divided into three categories. The first one is the biological degradation, that means the decrease in the soil organic matter or loss of the biodiversity, and loss of the soil and the increase in the soil-borne pathogens that results in the reduced carbon sequestration and impacting the nutrient regulation in the soil system. The second degradation form is the chemical degradation, that is nutrient imbalance, acidification, pollution or contamination of the soil, salinization, volatilization or leaching losses of the heavy metals or nutrients, and reduced cation exchange capacity, and this leads to the low water holding capacity of the soil, environmental pollution, restricted root growth and also salt toxicity to the plants. The third form of the degradation is the physical degradation, that is the soil sealing, surface sealing or erosion, crusting, compaction, waterlogging and desertification. All these results in the breakdown of the soil structure, reduced soil permeability and obstruction in the plant growth, and all these physical, chemical and biological degradation cause the lower productivity of the crops. And conventional agriculture is further intensifying these issues. Practices like excessive tillage, monocropping, overuse of the chemical fertilizer and faulty irrigation practices degrade the soil health, and also a decline in factor productivity, cause stagnation in the yield and sinking farm profitability, lower the groundwater table, loss of biodiversity and contributing to the climate change. So these challenges are pushing us to find the alternative and multifaceted practices like crop diversification, integrated farming system, organic agriculture and efficient use of the resources, and most importantly conservation agriculture. So now the question is that what is conservation agriculture? As per the Food and Agriculture Organization, it is a concept for resource-saving agriculture crop production which is based on enhancing the natural and biological processes both above and below the ground surface, and as per the FAO definition, it is achieve the acceptable profits, high and sustained production level while conserving the environment, and it is also aims to improve, to conserve and make more efficient use of the natural resources through the integrated management of the available soil, water and biological resources combined with the external inputs, and it is also termed as resource efficient or resource effective agriculture. Now coming to the principles of conservation agriculture, there are three core principles of the conservation agriculture. The first one is the minimum soil disturbance, where no tillage or zero tillage is followed for direct seeding or placement of the fertilizer into the soil without any primary or secondary tillage operations. The second one is the permanent soil cover, either by crop residue mulching or by growing the cover crops. Here at least 30% of the soil surface should be covered with the crop residue to reduce reduce the soil erosion and enhance the water conservation into the soil system. The third principle is the crop diversification, either by the crop rotation or by the intercropping. Here the main objective of the crop diversification is to break the disease or pest cycle and to enhance the nutrient cycling from deeper layers to above layer, and also to enhance the microbial population by providing the different food substrate for the microbial populations. If we talk about the global adoption of the conservation agriculture, then as of 2018-19, conservation agriculture was practiced over 205 million hectares of the land, representing 16.5% of the global cropland, with 92% increase since 2008-9 and 13% with since 2015-16. It is showing the increased interest of the farmers with this system for sustainable production and agricultural land management. If we talk about the leading countries under conservation agriculture, then USA, Brazil, Argentina, Canada and Australia are the leading countries, and in India it is only practiced on 3.5 million hectares of the land, especially in the Indo-Gangetic plains with zero-till wheat and direct seeded rice. In Madhya Pradesh, conservation tillage and intercropping is practiced in soybean wheat system, and in cotton system it is practiced in Gujarat and Maharashtra. In Karnataka and Andhra Pradesh, CA is mainly practiced in the dryland agriculture, and in Odisha and Chhattisgarh, government programs and NGO are promoting the conservation agriculture among the tribals and marginal farmers. Now coming to the conservation agriculture practices, it includes several practices including the managing topography, where less than 2% slope involved the agronomic practices and more than 2% slope mechanical measures are followed. It includes the contour farming. Here crops are grown along the contour and against the slope, and then strip farming. Here the erosion permitted crops are alternated with the erosion resistant crop. Then waterways. Here the grasses are grown in the path of water flow. The second one includes the conservation tillage, where at least 30% of the soil surface should be covered by the crop residue to reduce the erosion either by wind or as well as water erosion. Then it includes the no tillage or zero tillage, where the soil left undisturbed from sowing to harvesting operation, and soil is disturbed only for sowing the seed or the placement of the fertilizers. The second one is the reduced or minimum tillage. Here is soil is disturbed to break the hard pan or lose the compact soil. The weed management is done by using the herbicides. The third one is the mulch tillage. Here the crops are grown with residue mulch only itself, and the residues are not incorporated into the soil with the machinery. Now coming to the third important conservation agriculture practice, it is maintaining the organic soil cover. Maintaining permanent or semi-permanent soil cover is essential to protect the soil physically from the sun, rain and wind, and also feed the soil biota. It can be either by mulching or by growing the cover crops. Mulching can be organic soil cover or inorganic soil cover to protect the soil from the splash erosion or surface runoff, and also improve the soil structure by adding the organic matter to the soil. And growing cover crops that should be multi-purpose, like green gram and cowpea, that can benefit both for the soil erosion as well as gain purpose, and also can be used for the feed for the livestock. The fourth important conservation agriculture practice is the diversification of the crop rotation. It should integrate the deep rooted crop with the shallow rooted crop into the cropping system. Then the fifth one is the use of the specialized machinery or equipment under the conservation agriculture. It includes the happy seeder, zero till planter or raised bed planter or laser leveler for the adopting the conservation agriculture. Crop rotations under conservation agriculture is both diverse and strategic. It emphasizes on the economical and ecological benefits, especially in both the irrigated and rainfed conditions. For example, zero till wheat after the soybean and chickpea after the maize residue helps to maintain the soil fertility and also reduce the pest pressure and weed competition with the field crops. Now coming to the conservation agriculture and ecosystem services, first we should know that what is ecosystem services. It is the benefits provided by the nature to the society, and it is classified into four categories, and that is supporting services, regulating services, provisioning services and cultural services, and all these are interconnected, and this also operate at field as well as landscape level. A major difference between the conventional and conservation agriculture is that their ability to harness the ecosystem services in in the field for the production and across the landscape for the society and environment. And in the conventional agriculture, soils are degraded and all the soil functions are decreased and prone to the dysfunctions. Now coming to the ecosystem services which are provided by the conservation agriculture includes the provisioning services. That means the products obtained from the ecosystems. It includes the crop or food production, fresh water availability, raw material including fuel, wood and fiber, then biochemical or genetic resources. The second one is the regulating services. That means that benefits obtained from the regulation of the ecosystem processes like the carbon sequestration, soil aggregation, moisture conservation, climate regulation, energy use and efficiency, waste decomposition, detoxification, pest and disease management, crop pollination and etc. The third one is the supporting services that are necessary for production of the all other ecosystem services including the nutrient accumulation and cycling, primary production, soil health, biodiversity and habitat provision. The fourth one is the cultural services that are the non-material benefits obtained from the ecosystem. It includes the cultural or intellectual inspiration, recreational experiences and scientific discovery as well as landscape aesthetics. Beyond the ecosystem benefits, conservation agriculture offers benefits across the agronomic, physical, chemical, biological, ecological and hydrological domains. Agronomic benefits are improved stable yield, sustained yield and effective productivity is also increased, net primary production is higher and quality of the produce is also superior. In hydrological benefits, it reduces the runoff, soil evaporation and increase the soil water seepage, infiltration and groundwater conservation into the soil. In ecological benefits, there is increase in the eco efficiency and use efficiency and also higher natural processes and ecosystem carbon budget, while reduction in the loss of the water and nutrients. The biological benefits are the improved soil biodiversity, higher microbial biomass carbon, improved enzymatic activities and earthworm activities, increased deep incorporation of the biomass and soil organic carbon pool. The chemical benefits are the improved nutrient cycling, better soil reactions and reduced leaching, pollution and losses of the runoff and erosion. And the physical and mechanical benefits are the favorable soil structures, reduced erosion, better soil temperature regulation and better favorable energy budget and also reduced crusting. So overall this result in the improvement in the environmental quality and improvement in the soil quality, and all these benefits contribute to a more resilient agricultural production system. Besides these benefits, conservation agriculture also offers some practical advantages like laser land leveling can save up to 25 to 30% of the irrigation water. Zero tillage can cut the fuel and labor cost by up to 70%. The fertilizer use can be reduced by up to 50% and pesticide and herbicide use by more than 20%. A reduction of 13 tons per hectare has been reported in the greenhouse gas emission under the conservation agriculture as compared to the conventional tillage. It also buffers the crop against the climate stress like terminal heat stress in the wheat during the grain filling stage can be mitigated by the conservation agriculture. It has been reported that zero tillage with crop residue can reduce the total seasonal runoff by up to 80% over the conventional tillage. And chart and co-worker has been reported that peak rate of runoff can be reduced by up to 73% under the zero tillage with residue mulching as compared to the conventional agriculture. So it offers the several advantages including the long-term cost saving under the conservation agriculture with stabilization of the yield under the climate stress conditions. Despite these advantages, the adoption of the conservation agriculture based system is limited due to the mindset barrier, lack of the knowledge and awareness, sowing problem with the loose residue, weed menace, insect, bird and rodent damage are increased under the CA system. Then lack of the appropriate machinery, especially for the small and marginal farmers having small land holdings. The third constraint is the competing use of the crop residues, especially for the as a feed for the livestock and fuel and paper purpose or biofuel purpose in the industries. So how these constraints can be addressed for wider scale adoption of the conservation agriculture? The solution for the competing use of the resources is to balance between the retention and use of the crop residue for the feed or industry under the low rainfall conditions, that is low residue production, and they find the alternative or economic use of the crop residues like composting or developing CA-based seeders for the high residue levels that should be under irrigated condition where the residue production is higher, and the residue burning should be completely avoided. And the solution for the lack of appropriate machinery is to developing the CA-based machinery for the small and marginal land holdings, and also providing the machinery by developing the custom hiring centers at the village level. And the solution for the mindset variable is by changing the mindset of both the farmers and policymakers, and also by conducting the farmers training at and field level demonstration, and also extension activities for the large scale adoption of the conservation agriculture practices. In conclusion, conservation agriculture is a resource use efficient way to boost the farm productivity, profitability as well as sustainability. It is applicable to all the agroecologies with local adaptations. It provides better option for adaptation and mitigation to environmental stress, including the climate change. Location specific modifications in conservation agriculture technologies are required for realizing its full potential, and it may play a great role in reducing the global warming potential as well as environmental footprints. And integration of the breeding with system agronomy is required for wider scale adoption and in harnessing its full potential. And farmers participatory research for accelerating the adoption of CA technologies is a must, and the development of the farm equipment suitable for the small land holdings should be economically viable. Thus, it can play a major role in mitigating the climate change as well as ensuring the food security. Thank you for your kind attention.